All right, hello again, everyone. Noah Housley with some Chem 105, just study practice. Today I'm going to go over the lecture of 3.5 to 3.6. Again, this was a rather confusing one. So, the point of this lecture, or the point of these chapters, is they are solving the problem of the Bohr model. There are three problems with the Bohr model. It only works for one electron. It doesn't give the why of why the energy levels are quantized. And it doesn't say why electrons don't spiral into nucleus, because if a nucleus is positively charged for the protons and an electron is negatively charged, opposites attract, and so it should just go in. So why doesn't that happen? So some scientists looked to solve this. First, to solve problem 3, Louis de Broglie, came up with this equation, which says that matter moves in waves. This was proven after people shined a light through material, and there was diffraction. Really a laser through material, so there was diffraction. And this is on our equation sheet, okay? So this said that instead of, like the Bohr model says, a circular orbit, it followed a wave kind of orbit. So this meant that for this to work, though, they have to be standing waves. Emphasis on standing waves. If it wasn't, then the wave would dissipate. Does that make sense? So these waves don't, they really complement each other, and they don't interfere or decrease one another. So it's not a wave where it, something like that, where added these together, it would decrease the two. But these are standing waves where the nodes cross at the same point, and so it's not being dissipated at all. So since it's not being dissipated at all, it's a standing wave, the electron stays away from the nucleus because it's in a constant motion. So, and then this equation, I'm not sure, this wasn't on the homework, but this just says that n has to be an integer. So this also proves that since it is in waves, it shows that standing waves have to have an integer, or else it wouldn't be a standing wave. It also shows that in the Bohr model, there are energy levels. So these two, this also complements the Bohr model in saying that these are standing waves. Okay, sorry. Then Heisenberg came around, and he said that, well, now there's a problem of where is the electron? He said that you can't really find where it is because it's in a wave, and you can't really say where is the wave on a wave. It just is the wave. So he said we can find, even though we can find the velocity and the mass and find the wavelength, that there's still an uncertainty of the position. So change in x in the position there. So this equation is also on your equation sheet. Just be sure that when you're given a percentage of a velocity, it just goes in right there. Okay, and mass is a constant most of the time because its mass doesn't change on an object that you'll be using. So put the percentage into there, and what that's saying is it's the percentage of that velocity is uncertain. And so that's what you'll do, because it is the change in velocity. Okay, so since we found that measuring where the electron is was super difficult, we came up with this uncertainty equation, which says which then Schrodinger came to say there has to be places where they could be. And so in all these possibilities where they could be from the uncertainty equation, Schrodinger came up with another equation that got it down to 90% of most likely where it could be. And so it's a more exact way of telling where the electron is. He called these orbitals. And so it's a really long equation. It's not on the equation sheet, so I'm guessing it's not going to have to be used. It was on the slides, though, if you have any questions. What it's asking, though, on the homework is about psi. So I didn't know how to spell psi, so I tried, and and so I just ended up drawing the guy from Duck Dynasty. So psi is equal to it's the solutions to the equation, basically, of where it is. And when you square the psi, so I squared psi, then you get orbitals. And you're also going to have 3 quantum numbers for an orbital. You have n, which tells you the energy level, L, which is more of like a cursive L, and it tells you the shape of the orbital, and m of L, subscript L, tells you the orientation. So, for example, you could have an orbital. I'm going to try and draw a 3D thing here. And you can have an orbital that goes kind of like this. Like this. And these are all filled in here. So these are all possibilities of where the electron is in the atom. So L is going to tell me the shape. So is it like this, or is it more like just a round blob? Energy level is what I get from N. And then orientation, so is it like this, or is it upside down, kind of thing. There's a 4th number, which is m of s, and that talks about the spin. This is electron specific. And we'll get that to the, I guess, next sections in the chapter. But this is going to tell us if the electron is spinning up or down in the orbital itself. And so we'll learn about that. All right, that ends this video. Thanks for watching. Post any questions.